Okay, today we're going to be doing lesson 10.3, which is operations with radical expressions. You're going to be learning how to add, subtract, multiply radical expressions. And the main thing is a radical expression is going to be a lot like looking at variables. So you almost have to think of it as like terms. Something like if you had 2x plus 3x, you could add those and you would have 5x. Same thing goes with radicals. If I have something like 2 square root 2 plus 4 square root 2, I can add those together. But they have to have the same square root. So we'll be looking at that. So this is lesson 10.3, operations with radicals. So the first thing we're going to look at is simplifying sums and differences, so adding and subtracting. And this is where it's similar to looking at like terms when you're adding and subtracting variables. So you're going to treat the radicals exactly like you would a variable. Which means you can combine like radicals so they must be the same. And then you're going to add or subtract them exactly like you did variables. So you're going to add or subtract the coefficient in front of the radical and keep the radical the same. So again, think of this like if I was adding 2x plus 3x, I have 5x. X just comes over as it is. Same exact thing is going to happen with these radicals. So the first couple examples, we're actually going to have like radicals to combine. This is example 1. We're going to do several of these just to see. It says simplify square root of 2 plus 3 square root of 2. So again, think about this as just like a variable. I've got this like radical of square root of 2, so I'm going to add my coefficients. And look right here and think about what coefficient you would actually have there. And you should have realized it's a 1. So we have add our coefficients. 1 plus 3 is 4. And then you bring the root over, so square root of 2. And you're done. So make a little note, make sure there's a 1 here. Don't forget about those 1s, they're easy to forget about. Alright, let's look at a couple more. So we have negative 3 square root 5 minus 4 times the square root of 5. So again, I see a like radical. So I'm just going to bring that radical over and I'm just going to combine the numbers in front. So negative 3 minus 4 is negative 7, and then I bring over the root 5. So negative 7 times the square root of 5. C, square root of 10 minus 5 square root 10. So I look and I always make sure I see that like radical there, because there will be some that don't have it. So try it, see what you get right now. And you should have had a negative 4 square root 10. 1 subtracting 5 is a negative 4, and then I bring over my square root of 10. Don't forget about that 1. Okay, try one more. 4 square root 5 subtracting 2 square root 3. What'd you get? Okay, you actually should have had 4 square root 5 subtracting 2 square root 3. And if you look at it, it's because you don't have a like radical here. So you can't even combine those. And neither of these radicals break down to give you a like radical. In one of our upcoming examples, we're going to start looking at how we might be able to break these down. But in this case, I wanted you to see that square root of 5 isn't going to simplify at all. There's no perfect square factor in it. Square root of 3 doesn't have a perfect square factor. So there's nothing I can do with that. It would be like having a 2x squared minus 2x. You just wouldn't combine them. They just stay there. So always remember that. So this one doesn't combine. Because there are not like radicals. And they are already simplified. Okay, so now let's go on to example 2. Example 2 is actually going to be looking at things that don't have like radicals, expressions without like radicals, but we can actually do some work to get them to be alike, or possibly get them to be like. So, let's look at the first one. 7 square root 3 subtracting square root 12. What I recommend that you do on your homework for these is actually have a little space off to the side, kind of like we've done in the past, where you set up an area for your work. And I would do this on these for sure. It just gives you a space to show all of your work that's going to allow you to keep this nice and ordered here. So if I look at this, I have 7 square root of 3. Square root of 3 doesn't simplify at all, but I notice that from lesson 10.1, square root of 12 does simplify. So what I'm going to go ahead and do is go over to the side of my work area, and I'm going to break down the square root of 12. And when I break down the square root of 12, I realize I have the square root of 4 times the square root of 3. And this ends up being 2 times the square root of 3. Square root of 4 is 2, square root of 3 comes over. So if you notice, now you have like roots. So you're going to rewrite it 7 square root 3 subtracting 2 square root 3. And once you do that, you just combine your coefficients here. 7 minus 2 is 5, and then you bring down your root. So 5 root 3. Okay, let's try another one. 3 square root 20 subtracting 2 square root 5. So again, I look and I notice they're not like roots, so I can't combine them right now. Square root of 5 isn't going to break down at all, but the square root of 20 will. And so I'm going to break down the square root of 20. So go ahead and break that down. And you should have had square root of 4 times the square root of 5, which ends up giving you square root of 4 is 2, and then you bring over the square root of 5. So now you rewrite it. You have to rewrite it. You have to remember this 3 that was already at the front. So this 3 actually comes down times, and now you have your 2 square root 5, subtracting 2 square root 5 there. So this 2 root 5 came from the 20 breaking down. The 3 dropped down, and then the 2 root 5 here just dropped down. So now I can go ahead and multiply my coefficients here. So I have 6 square root 5 subtracting 2 square root 5, and my answer is 6 subtracting 2, which is 4, and root 5. Okay, let's look at one more of these. 3 times the square root of 3, subtracting 2 times the square root of 27. Okay, same idea here. 3 doesn't break down into a perfect square, but 27 does. Only difference is that now I already have a number in front of this root and this root, so I just have to be careful of those and make sure they come down. So if you want to, you can bring 3 square root 3 down right now, subtracting 2 times, and then that way you're ready to put whatever this 27 breaks down into right here. So we're going to go break down the square root of 27. And when you break down the square root of 27, you should have had square root of 9 times the square root of 3. The square root of 9 is 3 root 3. Now some of you might have just brought this 2 over here, put it in front of the 27, and then you'd have 2 times 3 root 3. So that's perfectly fine also. Or you can bring that 2 down now, and then you have times 3 root 3. You just need to make sure you combine these. It's order of operations. Multiply before I subtract. So now I have 3 square root of 3, subtracting 2 times 3, which is 6 square root 3. And now I just simplify my coefficients. I have the same root. So 3 minus 6 is a negative 3 root 3. And I'm done. So if you need a little more time to look at that, hit pause now and take a look at those examples a little closer. And we're going to go ahead and fill in on the right. So this was simplifying to combine like radicals. And you just need to remember, break down any square root that has perfect square factors. If you end up with like roots, with like radicals, simplify them. Okay, if you ever break something down here and you don't have like radicals after it breaks down, then you would go back to thinking about that first example, 1D, where they weren't alike, so you would just bring them over individually. That's as simplified as it can be at that point. Okay. Now we're going to look at multiplying these radicals. And the really nice thing about this is that you're really not learning anything new here. You're just applying rules that you already know to these radicals. So they really shouldn't be that difficult as long as you follow the rules that you've already learned. So this is multiplying. We'll talk about dividing another day. It's a little bit longer. So this is example 3. And again, we're simplifying all of these because they're expressions. They're not equal to anything, so we're just simplifying. We're not solving. So I have the square root of 3 times the square root of 6 plus 7. And already you should probably know what you're supposed to do here. Hopefully you thought to yourself, distribute. And if you did, you were right. So you're going to use the distributive property. And like I already said, nice thing is you follow the rules you already know. Which is great. Okay, one of the rules you already know, but you just need to remember here, is that when you multiply two square roots together, the square root stays. Okay, we're used to kind of canceling things out sometimes. But the square root stays. All you're doing is multiplying the two numbers underneath it. And then when you multiply square root times a number that's not under the square root, like this one, they're just going to end up side by side. So again, think about it in terms of having a variable there. Okay, and then always simplify if needed. Simplify the square root if needed. And then I just said the other part that I was going to have you write down, which is when you're multiplying a square root and an integer, they go side by side. So, if you need to, pause this and finish writing. Otherwise, we'll go on to the example. So if we look here, you're just going to distribute like you've learned in the past. So it's the square root of 3 times the square root of 6. They're both square root, so I just bring my square root down and I multiply 3 times 6, which is 18. Then I have the square root of 3 times 7, which is plus 7 root 3. You always put your square root after the number. Now we need to think about simplifying if needed. So at this point, these can't be added together. They don't have like roots. But I do see that 18 has a perfect square factor in it. The perfect square factor was 9. So I need to break that down further. So if I have a workspace over here, I would have the square root of 18, and I would go ahead and break that down. Square root of 9 times the square root of 2, which is, remember when you take the square root, you drop the square root. So square root of 9 is 3, and I have a root 2 that comes over. And the square root of 2 doesn't break down any further. So now I have 3 square root 2 plus 7 square root 3. There's my 3 square root 2, which was 18 broken down, simplified. 7 root 3 didn't simplify anymore. And can I combine these now? You should have said no, because not like roots. So this is your final answer right here. Oops. Is final answer. Okay, so that's your answer right there. And that says this is final answer. Almost forgot is. So it's that easy. Don't make it more difficult than it is. Okay, example 4. Again, you already know the rules for this, so as you're writing it out, look for it, and hopefully you will see what you need to do. It's either going to tell you to multiply or to simplify. And this first example is the square root of 5 subtracting 2 square root 15 times square root of 5 plus 2 square root 15. So hopefully all of you recognized that you have 2 binomials. And when you go to multiply 2 binomials, you have a couple different ways that you've learned that are fine whichever way you want to do it. If you notice here, you can use FOIL, if you call it FOIL, or distributing, or you can use a rectangle. So because we always started with the rectangle, in the first example I'm going to go ahead and use the rectangle, and then we'll do another one of these and I'll use FOIL, so that you have one of each for what you've been doing. So we're going to go ahead and set up a rectangle. And remember, these are the 2 binomials. We're not factoring, we're multiplying. So these go on the outside and we're finding what goes on the inside. Factoring, we would be putting stuff into the rectangle, pulling out the factors. So I have the square root of 5 subtracting 2 root 15, and then the square root of 5 adding 2 root 15. And hopefully some of you have already noticed that you have basically something that has exact same first term, exact same last term, opposite signs in the middle. So some of you might already know what's going to happen with your final answer here. Okay, at this point you should be getting pretty good with understanding square roots. So remember here, if I have the square root of 5 times the square root of 5, I have the square root of 25, which is 5. So these double when they're exactly the same. It's that rule we learned the other day where I can just bring down 1, 5. Okay, if you don't understand that, think about it this way over here. Square root of 5 times square root of 5 equals the square root of 25, which is 5. Okay, now I need to multiply these two together. I'm only going to multiply what's under the square root with what's under square root. What's on the outside can multiply with what's on the outside. So 1 times a negative 2 is a negative 2. And then 15 times 5 is the square root of 75. Now I'm going to do the same thing here. Positive 2 times 1 is positive 2. 15 times 5 means square root 75. Okay, now this gets a little tricky and you need to really watch it and be careful. I have 2 times a negative 2, which is a negative 4. Then I have the square root of 15 times the square root of 15. Same rule applies here. Don't waste your time multiplying 15 times 15 because you already know whatever that answer is, if you don't already know it, is just going to be 15. So we have negative 4 times 15 in this one box of our rectangle. So we need to actually multiply it out. And negative 4 times 15 is negative 60. So that's the answer for that rectangle right there. So now we're going to write out our terms. So we have 5 subtracting 2 root 75, adding 2 root 75, and then subtracting 60. And hopefully by now you see what's going to happen to the middle term. You have a negative 2 and a positive 2, so they actually cancel. And if you need to think about this, it's because a negative 2 plus 2 would be 0. So you'd have a 0 times the root of 75. Well, you've all learned that 0 times anything is 0. So that cancels. Middle terms cancel. And you should think about that because it was a difference of squares. We had same first term, same last term, opposite signs in the middle. Those difference of squares are the ones where you end up with just 2 terms at the end. Now in this case, our 2 terms are alike, so we can actually combine them. We end up with 5 subtracting 60, which is a negative 55. So your final simplified answer is negative 55. You went from all that up there, ended up becoming a negative 55. So we're just going to write one quick note about the binomials. This is for example 4, which is binomials. And you just need to remember, use FOIL or a rectangle. And then the other thing that you need to remember is the rule about matching square roots multiplied are one of the number. So for example, if I had square root of 3 times square root of 3, I just have 3. Okay, so let's go ahead and try one more of these. We'll just call this 4b. And we're multiplying 2 square root 6 plus 3 square root 3 times the square root of 6 subtracting 5 root 3. So in this case, you don't have a difference of squares. You have some like radicals, but you don't have a difference of squares. Difference of squares, you'd have to have the exact same b, which you don't, and the exact same a, which you don't. You do have your opposite signs, though. So we're going to practice this one with FOIL, or just distributing if that's the way you remember it. So remember, you multiply your first term times your first term. Remember, square root of 6 times square root of 6 applies to this rule right here. So I just have a 6. So I have 2 times 6. Or, if you needed to think about it that way, 2 times the square root of 36. Square root of 36 breaks down into a 6. So I have 2 times 6, which is 12. Okay, then we'll go ahead and use purple for the next one. Well, purple might not be dark enough. Let's use red. So now 2 times the square root of 6 needs to multiply to a negative 5 root 3. 2 times a negative 5 is a negative 10. And then square root of 6 times square root of 3 is the square root of 18. Okay, now I'm going to multiply 3 square root 3 times the square root of 6. And it's going to be hard for me to draw my lines because I forgot to leave a space there. But we're going from here to here. So 3 times 1 is 3. And then square root of 3 times square root of 6 is square root of 18. And then now my last set, which is these two. So I have 3 times a negative 5, which is a negative 15. And then square root of 3 times square root of 3 is the square root of 9, which is 3. And I should have multiplied those together, but that's okay. I can do that in the next step. So I'm just going to have 15 times 3. Okay, now I notice that the square root of 18 breaks down. So over on my work, I'm going to break down the square root of 18. We've been breaking down the square root of 18 enough to where you should probably know that the square root of 18 is breaking down into square root of 9 times square root of 2, and the square root of 9 is 3. So it would be 3 root 2 here. So I'm going to rewrite this right now with the broken down 18 here and here, and I'm going to multiply negative 15 times 3. So I end up with 12. Subtracting. I still have this 10. I can't lose it. So I have 10 times, and now I said I'm taking out a 3. So I have 3 root 2, because remember it was 3, 2, plus 3 times 3 root 2. That's that 18 right there. Subtracting 45. Now I need to follow order of operations, which is multiply here. So I rewrite it 12 subtracting 30 root 2 plus 9 root 2 subtracting 45. Now I'm looking for like terms. I have 12 subtracting 45, which is a negative 33. And I also have this matching root right here of root 2. So these are like terms, so I can combine these. Negative 30 plus 9 is a negative 21 square root 2. So this is my final simplified solution there, or answer, expression. I can't combine these because they don't have the same root. This doesn't even have a root at all. Okay, the other thing you could have done, right here you could have combined these. You would have had a negative 10 plus 3, and instead of breaking them down individually, you would have had a negative 7 square root 18. And then when you broke down the negative 7 square root 18, you still would have ended up with a negative 7 times 3, because of that square root of 9, which notice is a negative 21, and then square root 2. So you would have had the exact same answer either way. Break them down individually, combine them eventually, or combine them right away and then break it down. As long as you're following the rules, it all works. Okay, we're going to do one more example. This is the most difficult example of the day because it does look pretty confusing, but you need to try it and at least kind of look at it and see how it works and why it's used. It's basically for rationalizing the denominator when you have a binomial or more than one radical in the denominator at a time being added or subtracted. So, this is example 5. And we're rationalizing the denominator. It tells us to simplify 6 over the square root of 5 subtracting the square root of 2. I can't combine these square roots because they're not the same. So instead what I have to do is I have to try to think about what's going to give me something that's going to break these square roots down. And if you remember from example 4, when we were multiplying those two binomials that were a difference of squares, when we multiplied those together, all of our square roots ended up canceling, and we ended up with just an integer answer. So that's something called your conjugate. So what you're going to learn to do here is I need to get rid of these. So I'm going to think of this as one whole piece, and I'm going to multiply it by whatever the opposite sign is. Same A, same B, or same first term, same last term. Opposite sign here. It's making a difference of squares. And within making that difference of squares, my middle term, which has my square roots in it, it's going to cancel. So just kind of watch as we go through. Now remember, if I multiply the denominator of a fraction by something, I have to multiply by a value of 1, so I'm also going to multiply the numerator. So I have square root of 5 plus square root of 2 over square root of 5 plus square root of 2, and I'm multiplying it. Now, what I recommend you do is you just look at the top individually and the bottom individually. The numerator first, denominator second, then you combine the two at the end. So, numerator, or I'm just going to say top to make it easy so you don't have to think about which one's which, is 6 times the square root of 5 plus the square root of 2. So you're going to distribute and you get 6 square root 5 plus 6 square root 2. So that is your numerator for your new problem. Not that hard yet, right? So again, all we did was multiply by the opposite sign there. Same exact thing, opposite sign. So now you should see why it works. So now we're talking about the bottom, which is the denominator. And we have the square root of 5 subtracting the square root of 2 times the square root of 5 adding the square root of 2. So at this point you can either use the rectangle or FOIL. We should all get the same answer in the end. If you were using the rectangle, you'd have square root of 5 subtracting square root of 2, square root of 5 adding square root of 2. So notice here the square root of 5 times the square root of 5 is that 5, or square root of 25, which is 5. So you have a 5 here. Then you multiply square root of 5 times square root of 2 and you get a negative square root 10. Here you have a positive square root 10. what's going to happen to these two terms right here eventually? You should notice already they're going to cancel, so you don't even need them. They're opposite signs, and they're the exact same thing. Now the square root of 2 times the negative square root of 2 is a negative square root 4, which is negative 2. So I end up with only 5 minus 2 left, which is 3. So I've now rationalized my denominator because I have just an integer there. I don't have any square roots. So I'm going to rewrite, and I'm going to check to see if I can simplify. So I have the 6 square root 5 plus 6 square root 2. That's from up here when we simplified earlier. Divided by 3. Okay, we need to simplify further, and this is a really important rule to understand before we go on to our quadratic formula again, because you have to have this in order to simplify these. You have to be really careful. Right here I have 6, 6, and 3 are all my integers, each term. There's a term, and then I've got it divided by 3. Each of these terms has to have a common factor. Don't look at your radical. The radical doesn't matter at all. Each of these terms has to have a common factor to be divided and simplified here. 3 goes into 6, 3 goes into 6. I don't care about the square roots. So because of that, I can simplify this one step further. And I can say 3 goes into 3 once, 3 goes into 6 twice, and 3 goes into 6 twice. So now I end up with 2 square root 5 plus 2 square root 2 all over 1, which is 2 square root 5 plus 2 square root 2. And I'm done. In this case, the fraction actually went away altogether. Okay, this can't be added together because it doesn't have a like radical. So in case you're a little confused about that, let me show you an example of one that can't be simplified. Okay, this is an example of one that could not be simplified that looked like that, just so you see the difference. 4 square root 2 plus square root of 3 over 2. So if you notice here, I have 2 goes into 4. So that part could be simplified. But 2 doesn't go into 1 because there's a 1 there. And remember, I'm not worried about the square roots at all. I'm only worried about the numbers in the front. So this right here just stays like it is because there's no 2 doesn't divide into 1. It does divide into it, but it doesn't divide into it and simplify as an integer. So hopefully that helps you see that. Okay, so again I said these were called conjugates. So we're going to write some stuff on the left. Kind of a funny word. So these conjugates, you're going to use these to rationalize the denominator when you have two terms. With a radical in the denominator. Oh, I said in the denominator, sorry. And remember, we talked about you're going to set up a difference of squares. and then multiply the top and bottom of the fraction by it. So you set up that difference of squares. Same first term, same last term, opposite sign, multiply the top and the bottom by it. And then we looked at that whole piece. And then just remember the rule I just talked to you about. You can only reduce fractions when every term in the fraction can be divided by the factor or by a factor. So you can only reduce those fractions when every single term has it. And don't reduce an integer and square root together. Okay, what I mean by that is, let's just say, like here, let's say our common factor had been 2, I would only divide 2 into 6. I wouldn't divide 2 into the square root of 2 there. It's only the coefficients in the front. Okay, so this is the end of our notes for today. If you come to class tomorrow with the notes copied, then we'll go ahead and start working on the lesson that goes with it. And I can also answer any questions you have tomorrow in class about the notes.